For day 4 notes in Unit 7, this is called simplifying radicals. So that symbol right here is a radical symbol. The operation that you're doing is you're taking the square root of it. And normally we do problems that have perfect squares. So they come out pretty nicely, like the square root of 25. That would just be 5. Okay? That's 5 times 5 makes 25. Or like the square root of 49. 7, because 7 times 7 gets back to 49. So these are perfect squares. They create whole numbers. We don't have any decimals. Okay, but what happens when we don't have a perfect square? Like 48. Okay, so we have to figure out what to do. So what I do, for example 1, is I take the number and I figure out what times what can make 24. And there's lots of things. There's like 3 and 8, 4 and 6, 2 and 12. Okay, I'm going to pick one that has numbers kind of close together, like 4 and 6. Okay, but you could use any. You could use 3 and 8, you could use 2 and 12, it doesn't matter. And then I keep breaking it down if I can. So 4, it can break down to 2 and 2. 6 can break down to 2 and 3. So in this case, I have a nice even tree, vector tree, and all my numbers are in order, least to greatest. So if they weren't in order or your tree was kind of lopsided, go ahead and you would rewrite those numbers in order off to the side. Okay. Then you are looking for pairs that you can group together. So like I see that there's a pair of 2's here. And then 2 and 3 don't have a pair, so we're just going to leave them as extras. Okay. So then for your solution, you take one number from the pair, which is 2, and you put it on the outside. You multiply the leftovers together, and you put that number inside the radical. So let's try again. So in part B, we have 40. So 40 we could think of as 4 and 10. So 4 is 2 and 2. 10, 2 and 5. Okay, so we have a pair of 2's. The pair, take one number from the pair, put it on the outside. Take the leftovers, multiply, put on the inside. And that's it. Okay, for letter A, for 72, we're going to make a factor tree. So we could use, let's use 8 and 9 for 72. So that 4 broke down, the 9 broke down, and we have 1, 2, 3 2's, and we have 2 3's. Okay? We also have 4 x's. So let's go ahead and do our x's as well. Okay, so out of this entire group of numbers and letters, let's find all of our pairs that we can find. So I have a pair of 2, a pair of 3, and 2 pairs of x's. So what I do is I take one of the 2's and one of the 3's and I multiply those together. And that gives me 6. I have 1x and 1x. So x times x is x squared. Then inside of the radical, I put that leftover 2. Okay, part B, let's try again. So for 12, I can break it down. We could do 3 and 4. So I have 2 and 2 from the 4. So at the end of my branches, it looks like I have a 2, and a 3. I have 6 C's. So I find all my pairs. So I have it 1, 2, and I have 3 groups of C's. So that's going to be a C to the 3rd power. Leftover, I have a 3. Okay, for letter C, I have 90. So 90 can break down to 9 and 10. 9 breaks down to 3 and 3. 10 breaks down to 2 and 5. So writing my numbers in order, I have 2, 3, 3, 5, and I have 5 B's. Okay, so now I find all my pairs. Alright, so I take 1, 3, 2 groups of B, so that's B squared, and then left over I have a 2 and a 5. That gets multiplied to be 10, and then my other B comes back down inside the radical. Alright, letter D, 240. So it looks like most obviously you could use 10 and 24. So let's just do 10 and 24. So 10 would break down to 2 and 5, and 24, let's do 4 and 6. Okay, 2 and 5 cannot break down, but 4 can break down to 2 and 2. 6 can break down to 2 and 3. So I have 1, 2, 3, 4 2s, a 3 and a 5. Okay, so that should be 7. 1, 2, 3, 4, 5, 6, 7 W's. Alright, so let's find all the pairs. Okay, so you take 1, 2 from each group. So 2 times 2 is 4. W times W times W. W to the third. Left over, we have a 3 and a 5 that we multiply together, and then bring the W down.